If you're doing VCE methods this year, you need to be able to answer questions with parameters before your first SAC. In this case, we have f of x is equal to negative a outside of 1 plus x squared, where a is a non-zero constant, and we can see the graph of f of x generally represented here. We also have the graph of g of x is equal to x, so I'm just going to label that on my graph there. And the first part of this question asks us to find the value or values of a for which f of x equals g of x has two solutions. So the first instinct when seeing this question should be, I need to evaluate the determinant for this equation here. So what I need to do is just evaluate f of x is equal to g of x, move everything to one side, and then find the determinant. So what I do is I just replace those functions with its corresponding expressions. So I get negative a outside of 1 plus x squared is equal to x. The next thing I'll do is I'll just move everything to one side, and I'll also expand this bracket here. So I end up getting 0 is equal to ax squared plus x plus a if I move everything to the right-hand side. Now what I can do is I can find my determinant, and then I can say the determinant should be greater than 0 for two solutions. So just as a reminder, the determinant is equal to b squared minus 4ac, and this should be greater than 0 for two solutions. So therefore, I go ahead and evaluate the determinant. So determinant is equal to b squared minus 4ac. b is 1 in this case, so I get 1 minus 4. A is a. Don't confuse this a with the parameter a. This is just the general expression for the coefficient of x squared, and c is the general expression for just the constant. So a, which is the coefficient of x squared, is a in this case. And then c, the c value of our equation in this case, is also a as well. So don't get mixed up between the general representation of the coefficient of x squared and also just the parameter a. So what I can do is I can say, okay, delta is equal to 1 minus 4a squared, and I just simply have to solve this for when it is greater than 0. Now this is actually harder than it looks. If you've ever done inequalities with quadratics before, then you know that you have to sketch a graph of our quadratic expression. So what I need to do is sketch a graph of the delta, and I'll put the a on the x-axis. So if I just think about what this graph kind of looks like, it's a negative parabola with two x-intercepts, because I can solve it as 1 is equal to 4a squared, therefore 1/4 is equal to a squared, therefore a is equal to plus or minus 1/2. So you have negative 1/2, positive 1/2 as my x-intercepts, and again, the graph is a negative parabola, so it looks something like that. Now the reason why we need a graphical representation for this graph here is because now I can visually see where the graph, or for which domain, the graph is greater than 0, which is what I'm actually trying to solve for, because you can see that delta is greater than 0. So the best way of doing that is purely through a graphical representation. So you can see in this region here, the graph is visibly greater than 0, or visibly in the positive region. So again, this x-intercept is negative 1/2, this x-intercept is positive 1/2. So if I needed to add a domain to define where this graph is greater than 0, this will be when a is an element of negative 1/2 with a round bracket, because it's exclusive. I don't want it equal to 0, I want it strictly greater than 0, all the way to 1/2. Now, both are with round brackets because both of those points will be exclusive, which means that they have hollow points just like that. Now, before I finish this question, maybe some of you skipped off the video, but there's one important thing that I need to add to this solution. It's not when a is an element of negative 1/2 to positive 1/2. It's when a is an element of negative 1/2 to positive 1/2, excluding 0. So I have to exclude 0 in this case because it says that a is a non-zero constant. So if I just say that a is an element of negative 1/2 to positive 1/2, that actually includes a is equal to 0 as part of that set. And you could actually see why a is equal to 0 can't be a value in this case. It's not because they're kind of offensive towards 0 and they don't want 0 as a specific value of a. It's because if a is equal to 0, then our equation becomes f of x is equal to 0, and we lose all those properties that we get from a quadratic equation. So what I need to do is prevent that from happening in the first place by simply saying that a is the domain that we found. Yes, that's good. But then we have to exclude 0 as a value within this set to make sure that all of the solutions that we get in this set here correspond to giving us f of x equals g of x as two solutions. So this is our final answer, negative 1/2 to positive 1/2, excluding 0. And this is your final answer done.